This is Mrs. Palmer-Quay with the second video for Module 3. In this video I want to introduce you to the periodic table, and there will be some information in here that's not part of your textbook or not yet part of your textbook, but it's information I think is helpful for you to understand what we are using, why we have the periodic table that we have, how it is organized. So the periodic table can be thought of as an organizational chart of the elements, and it's organized by chemical properties. The periodic table has been developed over a number of years. Some of the elements have been known since ancient times, and of course the elements represent that substance that cannot be decomposed any further. But most of the elements were discovered and organized from about the 1800s onward, and we're still discovering new elements, more man-made elements today. The question that scientists were working with as they were putting together the periodic table is this one. How does each element react with other elements? Because it is the way elements react that have the reason for how things are organized in the periodic table. For example, these three elements, chlorine, bromine, and iodine, have very different physical characteristics. At room temperature, chlorine is a gas, bromine is a liquid, and iodine is a solid. But they all react in similar ways, and so they are grouped together because of how they react. So the groups in the periodic table, which represent the vertical columns, are elements that have similar chemical properties, and there are 18 vertical columns in our periodic table. Overall in the table, elements are also arranged in order of atomic number from the lowest to the highest, and the atomic number represents the number of protons in the nucleus of the atom. Neutral atoms, atoms without a charge, either positive or negative, will have the same number of protons and electrons. The periods, which give the periodic table its name, are actually the repeating patterns of chemical properties. These patterns repeat every 18 elements when you arrange them by atomic number, and so that is why we have 18 columns. There are 7 rows in the periodic table, and although the scientists did not know this in the beginning, we now realize that this pattern is caused by the arrangement of the electrons in the atom. We'll talk a lot more about the arrangement of the electrons as we go on in this course, but to just quickly give you an idea of what I'm talking about, in any atom you have a central nucleus which has your protons and your neutrons, and then the electrons are arranged in shells, in layers outside of that nucleus, and those shells have a certain number of electrons that they can contain before the electrons must go to a higher energy level. Here, this is a calcium ion or a calcium atom that we're seeing, and it has 4 energy level. The last electrons are placed in the 4th energy level, and the periodic table is arranged so that all elements that are on the same row have electrons in the same highest energy level. So all of the other elements that are on the same row as calcium will have electrons found in the 4th energy level. This is a very colorful depiction of the periodic table, and these colors help just show that our groups, the columns, have elements in them that share chemical characteristics. So this orange group right here I've just outlined are the alkaline metals, and they behave a certain way that is different than this purple column over here, which are our halogens. I'll be talking about some of these groups as we go on in the course, but for today, for the beginning of things, you only need to know about 2 major categories within the periodic table. Before I get to those categories, I want to talk just a minute about the atomic symbols that you see. Each of the boxes on the periodic table provides some very helpful information, and the atomic symbol, or here it's listed as the elemental symbol, is basically an abbreviation of the element's name. This abbreviation can be a single capital letter or 2 letters, 1 capital and 1 small. The elements that were discovered in the past may have names that are based on Latin, which means you can get some peculiar symbols that you need to remember, such as Na representing sodium. The modern elements are more likely to be English-based, and some of the most recent elements have interesting names because of the scientists that discovered them, such as Madame Marie Curie named an element she discovered polonium because she was Polish, and we have an element that was named after the very famous scientist Einstein. There is an Einsteinium. You'll find some other names that you recognize too if you go ahead and read them all. So the two groups that you need to know on the periodic table are what are the metals and what are the nonmetals. In the table that's in your book, you'll see a dark line going through the periodic table right here, which is bisecting these orange blocks. And on this particular table, those blocks are identified as metalloids. And I do want you to know a little bit about metalloids, but it'll all make sense to you as we get going. As you can see, the metals make up most of the periodic table. Most of the elements that are found in the world are metals. They are indicated on this table by being blue in color, whereas the nonmetals are green, and the nonmetals are found all on the right except for this one lonely hydrogen, which is listed over here on the far left for reasons that will become more obvious as we get into reactions. But when you're thinking about it, you need to mentally move it over here to the right. Let's talk about some of the characteristics of these groups. As I said, for metals, most of the periodic table are metals, and metals in general are good conductors of both heat and electricity. Metals are malleable. They can be hammered into thin sheets, and you can bend them without breaking. They are ductile. They can be drawn out into wires, which of course we know from the wiring in our house for electricity. Metals have luster. They are shiny in appearance. And all of the metals are solid at room temperature except for mercury. And you might be already familiar with mercury as a liquid in the thermometer. Nonmetals, that other major group on the periodic table, are basically the opposite of metals. They are poor conductors of heat and electricity. They can be found in all three states of matter at room temperature, but most are gases. And they're very important gases: oxygen, nitrogen, hydrogen, very important gases there. Solid nonmetals are brittle. They break when they are bent. They are not shiny. They are not lustrous. And in general, they also have lower melting points than metals. These three elements that I mentioned earlier are all nonmetals. Chlorine is a gas, bromine a liquid, and iodine a solid. Now, if you warm up iodine a little bit, it will turn directly from solid into gas. That third group along the stair step that is colored orange in this table are the metalloids. And they look like metals, but they behave much like nonmetals. In general, metalloids have some luster, but they're brittle. They do conduct electricity, but they do it at a much lower rate than the metals do. And because of that, these metalloids are important components of many of our electronic circuits. I know you've heard about silicon and the silicon chip and how that revolutionized our electronics industry. So several of the elements found along that stair step of metalloids are part of electronics. The periodic table, though we have it neatly divided with metals on this left-hand side and nonmetals on the right, in reality, as you move across the table from left to right, the elements go from being very metal-like on the far left to very non-metal-like on the far right, and a mixture in between. And so this metalloid column also then is kind of a nebulous way of defining it. Sometimes carbon or aluminum get added into that because there's a blending as the characteristics go. You move across the table. It's not all perfectly cut and dried. If you move from aluminum to silicon, there's not an abrupt change. There's more of a gradual shift of some of the properties. Make sure you take time to look at the periodic table, to start memorizing these atomic symbols. I will give you a list of what you need to know, but if I tell you, you need to do a formula that involves magnesium, you should know to go to the metal side of the table, or chlorine over here on the non-metal side. Practice getting a sense of where you find these metals and nonmetals because that becomes very important in writing formulas. This finishes what I want to say on this particular video, but we're going to be coming back to this periodic table over and over again.